Chelsea dropped a bouncy ball off the roof while Neri recorded its rebound height. The table at right shows their data. So when I take a look at this data, let's look at a couple differences here. If I take the 290 and divide it by 475, I believe I get 0.611. So I'm taking this 290 and dividing it by the previous term. If I take 175 and divide that by the previous term, I get about, 0.603. And if I take the 100 and divide it by 175, 100 divided by 175, it gives me about 0.56. So if I look at these values, I can see that, I've got a multiplier that's, somewhere close to 0.5 something. In fact, if I look at the last one, 60 divided by 100 is 0.60. So, there's a multiplier here. Of course, this is experimental data. It's not being generated by a function. But I'm using this data and I'm trying to come up with a function that models it. So to me, I would say if I took the average of these four ratios, I would say that the rebound ratio is probably somewhere around 0.59. In other words, I'm just thinking I'm just going to add these four numbers and divide by 4. And somewhere we're getting a rebound ratio of about 0.59. Now, if I want to, I'm also going to go ahead and plot this data. I want to take a look at it. So right now, if I take a look at this data, I went ahead and started GeoGebra while you weren't looking. And up here you can see I've entered my values 1, 2, 3, 4, 5 in the spreadsheet view. And then the next column over I've entered the 475, which was my start height, the 290, the 175, the 100, and the 60. So if I want to take a look at this data, I could select it all. Then I right click. It's off the screen, but I'm going to say create a list of points. You can see that on your screen. And that didn't show up as a list of points. Let me try that again. Create a list of points. And interestingly, it did show up. Let's see, view. I need to look at the algebra view. There's a list of points that occurred twice. So this list of points is here. I don't need to see it twice. But I need to take my x-axis and drag it down significantly. So let me drag this down so I can start to see some of these. There they are, right? So I need to go bring down to 475, which is about there. So here's these points. I could also take and drag this out a little bit more. But when I look at this, this is clearly not a linear function, right? A straight line doesn't go through these points. What's happening is every single time I'm multiplying by about 0.59 again. So times 0.59 times 0.59. So this is a definite example of an exponential function. In fact, this is kind of a preview of what's going to happen. But if I wanted to, I could figure out the 0th term. In order to write this function down, I need to know what the 0 term is before any bounces, because you can see this is after one bounce. But the first one, right, with before any bounces, if I take, instead of multiply by 0.59, remember I decided my average bounce here was 0.59. I could take and I could divide by 0.59, and when I do that, I get about 812.6. So this is probably what my initial drop height was, and then after one bounce it was here, a second bounce here, third bounce, fourth bounce, and then the fifth bounce. So I can model this with the following function, right? The height after any number of bounces is my initial drop height, or the 0th term, as we might start calling that, the 0th term, and then times 0.59 raised to the x power, where x is the number of bounces. So if I wanted to take a look at that in GeoGebra, I could just overlay that on top of it. So down here in the bottom where it says input, I could say, I want to, whoops, that jumped it off the screen. I could say I want to input y equals, and then I'll enter the 812.6, and then I'll go ahead and multiply that by 0.59. It's a little, if you don't know it, it's difficult, but this symbol right here is to the power of, and then I'm just going to enter the variable x. So when I have that, I could press, oh, I need to press enter, sorry. When I have that and press enter, you can see it overlays this function. So this function's doing a beautiful job, if you look at it, of figuring out about, right? There's some, some slightly above, slightly below, because again, this is based on a data set someone collected from observing the rebound heights, but it's still doing a fabulous job of modeling this data. Also, if I come back over here and look, it's kind of instructive to see that, yeah, around 812 is actually where it did start before any bounces, right? Before the initial release right there, the 0th term. Okay, so I think that's pretty much it for question 46.